Theobroma cacao, also known as cocoa, is a tropical tree. It originates from the Amazonian rainforest. It prefers temperatures above 25 degrees Celsius, precipitation between 1,500 and 2,000 millimeters, with no prolonged dry period. These conditions are found in the equatorial and some tropical regions at altitudes usually below 700 meters. The soil should be deep and fertile with good drainage. The lifespan of the cocoa tree depends on many factors, from 20 years in poor conditions to more than 50 years in good conditions. Selected trees start to produce 3 years after planting, but it starts to become economically viable after the 6th year. The tree can grow up to 15 meters high, but it is recommended to keep them shorter by pruning for easy harvest and good pest monitoring and control. It is usually planted under the protection of tall forest trees. The cocoa tree is an evergreen plant. Leaves grow in flushes that are determined by precipitation. Cocoa flowers are very small and fragile. Flower cushions can be observed over the trunk and branches. Several thousands of flowers are produced per year in every tree. Small midges ensure pollination. The pod setting is very small compared to the number of flowers, but it can still reach, on average, 100 fruits per year. However, most of the fruit will not survive. Only 20% reach full ripeness. The main cause of losses is wilt. This is a natural process by which the number of small fruit is adjusted to the actual condition of the tree. The better the condition of the tree, the higher the survival. Other important causes of losses are pests and diseases. The fruit of the cocoa tree is a pod. It is a husk containing 30 to 50 beans in a white, sweet pulp. Around 5 months after pollination, the fruit ripens. The beans and the fruit are processed into the cocoa ingredients. Cocoa trees are cultivated in tropical countries. West Africa produces more than 70% of the world output. So we'll first focus on this region to look at weather and crop patterns. The weather in West Africa is determined by the yearly north-south oscillation of the ITCZ. The ITCZ, or Intertropical Convergence Zone, is a part of the atmosphere rich in humidity with active cloud systems. In January, it's at its most southerly position. During the first 6 months of the year, it will move north. When the rain season covers the cocoa areas, it is the main rainy season. This occurs in May-June. In August, it is at its most northerly position. For Sahelian countries, it is the only rainy season of the year. But in the cocoa belt, the rains have stopped. Then it starts moving back south. When its rain system again covers the cocoa areas in October-November, it is a second rainy season. But because precipitation is much less than in May-June, it is called the small rainy season. Finally, the ITCZ leaves the continent. From December through February, the rains are rare in the cocoa belt. Dry winds come in from the Sahara Desert. This is the main dry season. The 2 rainy seasons result in 2 crops. Let's look at it in more detail. Let's start in May. It is the middle of the rainy season. The canopies are in a very good shape. Flowering is intense. In June, during the hot and sunny hours of the day, insects are very active and pollinate the flowers. Small pods appear all over the cocoa tree. This is the pod setting of the main crop. In August-September, the rains are much reduced in the cocoa belt, which leads to light water stress on the cocoa tree canopies. It's the time of year when the pods grow, and consequently, weather has a critical impact on the crops. If it's drier than normal, the survival of the pods will be low. And also, the development of the surviving pods will not be good, and the beans inside the fruit will be small. In short, the crop will be poor. In October, the rains come back. Soil moisture increases, and the cocoa tree recovers from the past water stresses with flushing new leaves. Pods, which are now 5 months old, are getting ripe. It's the time for the first main crop harvests. In December, a good part of the ripe pods is harvested. The fairly good condition of the tree again induces flowering. Pollination occurs, and by the end of December and early January, some new pods appear. This is the mid-crop pod set. In January and February, the rains are over the Atlantic Ocean south of the cocoa belt. Soil moisture drops, and cocoa trees suffer from the lack of water. This is the main dry season, just like the July to September dry season, but to a much greater extent. This very strongly affects both survival and pod development. Consequently, the volume of the mid-crop is 20% of the yearly output, while the main crop is 80% of the total. Also, in terms of quality, mid-crop beans are much smaller in size. Because the weather has such an impact, the volume of the mid-crops can be significantly different from one year to another, depending on how severe or how mild the main dry season was. In March-April, the main dry season ends. The rains return in the form of localized strong showers. With improved soil moisture, several flushing cycles occur to restore the canopies. Mid-crop pods ripen and are harvested in May. The timing of the start of the main rainy season in March-April considerably affects the timing of the next main crop. If the rains are early, recovery of the cocoa trees is early. Then the pod sets, and 6 months later, the harvest have a good chance of being early as well. We are back at our starting point. In May, the rains are abundant, the trees have fully recovered. Mid-crop harvests have just taken place, and flower cushions are free for the main crop. Cocoa is a tropical crop that mainly grows between 20 degrees north latitude and 20 degrees south latitude. The most important cocoa growing region is West Africa. Let's have a look at the first steps in the supply chain in the Ivory Coast, the world's #1 cocoa growing nation. In West Africa, the main crop is harvested between October and January. The fruits, or pods, turn yellow. It's a clear sign they are ripe and ready to be harvested. Beans inside green pods are not ready to deliver the right color and contain less fat. The pulp is less sweet, and the beans tend to ferment poorly. Farmers visit their farms during the harvesting season at regular intervals to harvest all the ripe pods. This operation takes some time, as there are around 1,000 trees per hectare. Depending on the pod load, it may take a week for one man to harvest 1 hectare of trees. Then all the pods in the farm are gathered in one place in preparation for the next step, pod breaking. Often, many family members and neighbors will come to assist in this work. The beans, covered with a white pulp, are removed from the pods. Pod breaking must be done within 1 day in order to get a homogeneous start of fermentation. This is the fermentation heap. Banana leaves provide excellent protection for the fermentation heap and are still permeable to the fermentation juices. Fermentation involves a series of complex biological and microbiological reactions that transform the cocoa bean. It has a key impact on the quality of the beans, and hence on the quality of the chocolate products. At this stage, precursors for color and taste are developed. Let's better understand what happens during this process. To sufficiently increase the temperature, it's recommended that the fermentation heap is large enough and well isolated from the outside cool air. Fermentation has two successive phases. First, an anaerobic phase, caused by yeast transforming sugars in the pulp into alcohol through heat and CO2 emission. The pulp is liquefied and drained from the heap. Secondly, an aerobic phase, caused by bacteria transforming alcohol into acetic acid, part of which migrates into the bean. The acid and the high temperature kill the germ. This leads to internal enzymatic reactions that are the precursors of the color and taste. They will later be revealed during the roasting and alkalization operations. To allow homogeneous fermentation and to start to fuel the aerobic phase, it's recommended to mix the heap every 2 days. For large quantities, as on Brazilian farms, wooden or cement boxes are used. The bottom of the box should always allow fermentation juices to drain out. The proper length of the fermentation process depends on the type of cocoa. Criollo is fermented for only 2 or 3 days, while Forastero requires 4 to 7 days. Poor fermentation leads to beans with more purple pigments and greater bitterness and astringency. Over-fermentation leads to dull, dark beans with little chocolate flavor and eventually off smells. Drying, mostly done by the sun's heat, decreases the moisture content from around 60% to 8%. This level preserves the bean from mold. Beans are spread on drying mats or in clean concrete floors. Depending on the weather, this takes between 1 to 2 weeks. During the drying operation, farmers remove foreign material like placenta or stones. Sometimes the weather changes, and farmers quickly need to protect their beans from rain. In Brazil, the most common method is moving the roof. When it rains, the roof is closed. When it's sunny, it's opened again. This can happen many times during the same day. Occasionally, the harvesting period falls in a rainy season. Farmers then have to resort to artificial drying. A hot pipe warms the surrounding air, which passes through a drying mat and the wet beans. The pipe should be well sealed to prevent smoke from leaking. This creates very bad off smells that can't be removed later during industrial processing. One tree delivers 18 pods a year in the Ivory Coast. One pod delivers 40 beans, which means 40 grams dry fermented beans. One person can break 2,000 pods a day, which gives 80 kilograms of dry fermented beans. It's estimated there are more than 800,000 cocoa farmers in the Ivory Coast, who produce, on average, between 1 and 2 tons of cocoa beans each. The first step of the supply chain is very fragmented. The farms are often located in remote areas. This makes it impossible for Cargill to deal with individual farmers. Still, Cargill's strategy is to get as close to the farmer as possible, with the intention of having access to the best quality beans and aiming at maximum remuneration for the farmer by providing a transparent buying system. This has resulted in a multitude of partnerships with cooperatives and the opening of up-country buying stations in the Ivory Coast. These stations allow the smaller and young cooperatives to have a faster rotation of their limited capital in trucks, compared to when they had to deliver directly to the port. After the cocoa has been collected by a cooperative or by a small middleman, it's brought to the nearest cargo buying station. In a few countries, like Brazil, the farmers sell directly to the industry. In Ghana, the buying of cocoa is government-controlled by the Cocoa Board. Licensed companies have small local buying points all over the country. At the buying station, each bag is sampled and checked for its moisture content. The beans are collected and brought to the lab, where extensive quality analysis takes place. If the quality meets our standards, the cocoa bags are accepted and stored. Soon they'll be made ready for bulk shipments to our export terminals in Abidjan and San Pedro, or to our plant in the Ivory Coast. Upon arrival at our export terminals, the cocoa beans are dried to prevent the development of mold. Dust, metal pieces, stones, and other foreign materials are also removed. After cleaning, the beans are usually stored in big bags until a shipment is ready. For reasons of efficiency, part of all cocoa that is destined for our processing plants outside the Ivory Coast is shipped in bulk. The cocoa tree originates from the Amazonian forest. In the 18th century, beans harvested from wild trees were exported from Belém, a port at the mouth of the Amazon River. The states of Pará, Rondônia, and Amazonas are still producing cocoa today. But since the end of the 19th century, Bahia is the biggest producer, responsible for more than 80% of the total Brazilian crop. In Bahia, farms are large, frequently over 50 hectares, and run by paid laborers. Today, this situation is rare in a world where smallholders, using only family labor on farms, usually smaller than 5 hectares, produce more than 90% of cocoa. There are 2 crops in Bahia, the main and the mid-crop. Harvesting the main crop usually takes place between September and December. Despite its name, since the mid-1990s, the main crop is smaller than the temporal crop, which is harvested from May to July. It's very important to take only golden pods, so the beans and the pulp are at the optimal stage for good fermentation. That is critical for the development of the chocolate color and taste in the final products. Pods are collected and brought to a central place. About 40 beans, surrounded by a white, sweet pulp, are extracted from the husk. For better quality, beans are separated from the placenta. When a certain quantity is reached, it's time to transport the beans to the fermentation and drying facilities. In Bahia, plantations are large and distances to cover from the fields to the farm buildings are sometimes long. People usually use mules to transport the fresh beans, as the terrain can be rugged. For larger distances and quantities, farmers prefer to use tractors rather than animals. Fresh beans are poured into wooden boxes. One box contains about 300 kilograms of fresh beans. They'll be left to ferment for up to 6 days. Every 2 days, the beans will be moved from one box to the next. This will mix and homogenize the mass of beans. Yeast and bacteria develop, degrade the pulp, and sugar is transformed into alcohol. After 2 days, the pulp is already drained out and the level of oxygen in the mass has increased. Bacteria transform the alcohol into acids. This, in combination with heat, kills the embryo, leading to internal enzymatic reactions in the bean cotyledons, which create the precursors of the chocolate color and taste. These precursors will be revealed later during roasting. After 6 days of fermentation, the beans are spread on barcassas to be dried in the sun. Especially at the beginning of this process, in order to avoid the development of mold, it's important to turn the humid beans by trampling or using a rake. Within a few days, the moisture content of the beans drops from 60% to less than 8%, a level that preserves the bean from mold. For protection against rain, it's possible to move the roof of the barcassas. The dry beans are finally put in bags and sold by the farmer to cargo. The bags are sampled. The collected beans undergo a series of quality checks: humidity measurement, cut test with detection of off smells, and visual assessment of defects. The next phase is the processing in our plant. What type of product will be produced? Does a customer need a special flavor profile for his end product? That is the starting point of Cargill's cocoa processing. The beans arrive at the plant from different origins and are stored accordingly. The beans now have to be cleaned. Non-cocoa materials will be separated from the cocoa beans. They are now stored in different silos. Selected beans are carefully blended in order to reach the desired profile. Cocoa beans roughly consist of two parts, that is, the kernel, called nibs, and the shell. In order to separate the nib from the shell, the beans are broken mechanically. The blend of nibs and shell will be sorted and sifted by a series of machines. As the shell is lighter, the two are separated by an air stream. It's very important to take out most of the sand and shells, as what is not removed here will show up later in the powder. The shell consists of stone cells, and this causes increasing wear and tear on the equipment used by the food industries. Damage to homogenizers is a good example. The shell is bacteriologically contaminated and has a heavy metal content higher than the nibs. Cargill endeavors to reduce the amount of shell in the process as much as possible. To achieve that, this step is applied 2 or 3 times. As a result of fermentation, cocoa beans are slightly sour and acidic. The pH value is around 5.5. Adding alkali increases the pH in the nibs. This is what is called alkalization, a process used to improve mainly the color but also flavor of the cocoa products. It is the intensity of the alkalizing process and the stage at which it takes place that determines the quality and final color of the product. The best method for color development is to alkalize nibs, which is what we do at Cargill. The first sterilization step takes place in this phase of the process. The second sterilization step takes place in the roasting phase, and it's a critical control point. If the temperature drops under the critical level, the production flow will be totally stopped. Roasting is a heat treatment used to develop the typical cocoa flavor. In the roasters, the heat is transferred to the nibs via conduction from the nibs that are in contact with the roaster walls, and via convection when hot air is blown through the nibs. To prevent flavor damage, the nibs are instantly cooled down. This phase is called grinding. The nibs are ground in 3 steps to be transformed into cocoa liquor. The first step is the knife mills, where knives rotate at high speed and produce a coarse paste. Then, the ball mills, containing metal balls, refine it, and finally another set of mills containing metal spheres of a smaller diameter refine the liquor further. The liquor then passes through sieves and a magnet before being stored in heated tanks. The liquor is now ready to be used as an ingredient in the food industry, mainly for chocolate production. In order to produce chocolate, we also need cocoa butter, which can be obtained by sending liquor to the presses. In this phase, hydraulic presses separate fat from the cocoa solids by forcing the liquor through a filter screen at a high pressure of up to 500 bar. When the liquor is pressed, approximately equal quantities of butter and cake are produced. Pressing takes place in cycles. The length of the pressing depends on the desired cake fat content. The higher the fat content, the shorter the pressing cycle. The butter passes a filter where the last solid particles are removed. Most butter will be partly or fully deodorized according to the customer's choice. This means that the aroma and flavor components are removed by applying high temperatures in combination with vacuum. The butter is ready to be shipped in bulk or to go to the tempering machine to be recrystallized and packed in boxes. Cocoa powder is obtained when the cake is broken and pulverized. During this phase of the process, we can also blend cakes to produce a wide range of powder types. In Cargill's plants, we can use two types of mills. The desired fineness for the customer can be obtained by using a classifier mill. As explained earlier, there is still cocoa butter in the cake, at a minimum level of 10%. It's very important to allow the butter to crystallize in a stable form, thus preventing the formation of lumps. To achieve this, cooling systems are used. It's also important that the powder is stored under the correct conditions for some time before packaging. Customers using large volumes of cocoa on one production site will gain efficiencies when they switch from the regular 25 kilogram or 50-pound bags to super sacks. These large bags contain up to 1,000 kilos or 2,200 pounds. Less handling is obvious. Smaller bags are labor-intensive. More powder is left behind in the smaller paper bags and will disappear as waste. This can easily result in a 1% yield improvement. In addition, the destruction cost of used packaging material is less. Using super sacks in the proper way will improve dust control in the production areas of our customers. Super sacks are used for many ingredients. Cocoa in super sacks needs much more attention than sugar, for instance. The standard bag size is high because powder is bulky. This may have an impact on the storage facilities. Equally important is the height between the floor and the ceiling where super sacks are discharged. There are many more details that need to be reviewed to make your system work efficiently. Think, for instance, about a so-called lump breaker. Obviously, the powder should be free-flowing, and all measures have been taken in our production process to ensure this. However, if the bags are exposed to heat during transport, or have transported over rough roads, the powder may have stiffened. Lumpy powder may not pass the dumping station unless this trembling device can be switched on. It may not be used often, but if you don't have it, you can really run into problems. Or think about this. Unloading can also become more efficient when panels are installed that can slightly push up the big bags near the discharge spout. It will push the powder from the corners of the bags to the center where the discharge spout is located. Another idea is to include in your equipment the possibility to suck the air from the bags after unloading. This will prevent cocoa dust from entering your production halls and can reduce cleaning costs. We like to advise you as well about the transport systems from your hopper to the next step in your production process. Transporting powder through pipes may pose some more challenges than you think. We have that knowledge in-house and like to share this with you. We have gained a lot of experience over the years concerning the use of these bags. Please contact us when you consider this type of packaging to make your system efficient. Cargill Cocoa's mission is to provide its customers with high-quality products. We combine these quality products with the necessary services to assist you in producing high-quality end products. Your questions about the use of cocoa products in your specific application are a challenge for our application team based in Holland. This team consists of technical service specialists who combine knowledge of cocoa with broad experience of the various applications.
Bye-bye. Have a safe trip home and we keep in contact.
In our head office in Holland, we are able to perform basic application tests.
Ja, het is een stuk donkerder.
Deze wat licht is en deze wat donker is.
Tailor-made solutions are one of the strengths of Cargill Cocoa. Being a part of Cargill creates even more opportunities to combine knowledge and expertise. For instance, our Cargill Cerestar R&D and Application Center in Vilvoorde. Here we can run pilot plant tests with all possible cocoa applications. Flavor evaluation plays an important role in our projects. All this testing is necessary to be sure we can offer you the best solution.
It was not easy, but the result is very positive.
It's our belief we should invest the maximum effort to offer you the best products and advise you how to use them in order to create a necessary condition for you to be successful. The Cargill Cocoa Application Department is ready to work with you, assist in your product developments, advise about the best ingredients, inform you about industry trends, and introduce new products for your convenience. Chocolate drinks are a very important cocoa powder application. In the choice of a cocoa powder for a chocolate milk application, the following aspects are important. First, the fineness of the cocoa powder. In the cocoa industry, the fineness of a cocoa powder is expressed as a wet sieve residue. Gherkin's cocoa powders have a very good fineness. Second, microbiological requirements. A low thermoresistant spores count is important. For many of its dairy customers, Gherkin's has developed tailor-made specifications with the aim of guaranteeing minimal spoilage of the final sterilized chocolate milk. Another aspect is shell. The shell content should be as low as technically possible, because the shell is a carrier of impurities, such as heavy metals, pesticide residues, and mycotoxins. It also wears down machinery, for instance, a homogenizer. Then, color. A choice can be made from a wide range of hues, varying from light brown to dark red-brown. The choice depends on the preference of the consumer and on economic considerations. A darker color is associated with a strong cocoa flavor. Of course, flavor is also important. The cocoa flavor depends on the type of cocoa powder and the amount used. Frequently, other flavorings besides cocoa powder are used in chocolate milk, such as vanillin. Finally, the alkalinity and pH. Both aspects of cocoa powder are closely related to each other. The addition of alkali during the process also increases the pH. The closer the pH of the cocoa powder is to the pH of milk, 6.7, the less impact it has on the thermal stability of a chocolate milk. Gherkin's applies a special technique during the alkalization process, whereby nice, intense, dark colors are combined with a relatively low pH and alkalinity. Cocoa powder dissolves only partly in milk. The rest remains dispersed as solid particles. If no special measures are taken, these particles will soon settle at the bottom and form a sediment layer. In order to prevent settling of the cocoa particles, a certain type of gelling stabilizer is added. This stabilizer is able to form a so-called three-dimensional network, in which the cocoa particles are entrapped and are thereby prevented from settling. The following aspects are important for the recipe of chocolate milk. Type of milk: whole, low-fat, or skimmed. The type and amount of cocoa powder. The amount of cocoa powder can vary from less than 1% to more than 3%, and the type and amount of stabilizer. After mixing the ingredients in the milk and a homogenization step, the chocolate milk is sterilized at 140 degrees Celsius for a few seconds, depending on the UHT equipment, and then quickly cooled. With UHT sterilization, there's a difference between direct heating and indirect heating. The most important factor in chocolate milk stabilization is the filling temperature. To obtain full, stable chocolate milk without any cocoa settling on the bottom, the filling temperature should be lower than 5 degrees Celsius. The aseptic conditions are also critical during filling. Cross or after contamination can cause severe product spoilage. For chocolate milk, there are some potential defects in the appearance. Sedimentation of cocoa particles. Sedimentation can be due to the following causes. The cocoa powder is not fine enough, the temperature of the chocolate milk bottled is too high, the concentration of stabilizer is too low. Another defect is layer formation. A too weak network causes layer formation. The entire network collapses under its own weight. Curdling. Curdling is caused by a too strong coagulation of the milk proteins. The degree of alkalization of cocoa powder is an important factor in relation to curdling. The application teams of Cargill Cocoa are daily assisting customers with practical, tailor-made advice. These departments advise on the types of cocoa powder that give the best results for a specific product and a specific method of production. Chocolate is one of the most wanted sweets throughout the world. It appears in a wide variety of products, such as bars, tablets, pralines, and as a coating for ice cream and cookies. As one of the major processors of cocoa beans, Gherkins is able to provide a wide range of products to fulfill your demands. From a botanical point of view, different species are cultivated. What's more, the beans have different origins with different climatic circumstances. This will strongly impact the cocoa bean, our raw material, and therefore the characteristics of the products, the cocoa mass and the cocoa butter. Next to the botanical and climatic differences, the treatment of cocoa beans is crucial to the quality of gherkins and products. The differences already present in this stage will have a major impact on the cocoa butter and mass in such important fields as taste, color, and fat content. In an application where such a large part of the recipe is determined by the raw materials coming from cocoa, the quality of the butter and mass is of the utmost importance. At Cargill, we're able to process the fermented and dried beans with the Gherkins technology in such a way that the original differences present in the raw materials will be maintained as much as possible. Next to origin, the roasting process is also a factor, greatly determining the development of the flavor components of the cocoa mass. Differences during the roasting processes will lead to differences in flavor profiles. A comparison between a medium and a strongly roasted cocoa mass may serve as an example. At the customer's request, unwanted acid flavors can be neutralized by a small addition of alkali during processing. On demand, we can also produce tailor-made roasting conditions and specific blends of beans. As a special treatment, Gherkins offers the possibility to include petsomizing of the cocoa mass. This will lead to a bland-tasting, very mild cocoa mass. Your conching time might be shortened. With our three-step refining process, we're able to supply a fine quality cocoa mass. The normal sequence of production will include the following processing steps: dosing of all ingredients, kneading, pre-refining, refining, and conching. To fulfill the demands for a mass that can be used by passing the refining step of chocolate making, we have designed a mass quality, which goes through an extra sieving step. The differences, as indicated in the cocoa mass, will also affect major aspects of the quality of the cocoa butter derived from it, such as, for example, hardness, crystallization speed, and taste. At Gherkins, we only produce the finest quality, a pure prime-pressed butter. Where pressing alone takes place, no chemical treatment. This high-quality raw material can be supplied as a non-deodorized as well as a deodorized cocoa butter. Deodorization takes place under very mild processing conditions, keeping the butter as natural as it was, and only removing some of the unwanted flavor components. For producing chocolate, among other things, crystallization behavior is an important parameter. To give the customer a better idea of this crystallization, we perform a Shukoff analysis on every cocoa butter lot produced. For this test, we fill the specially designed Shukoff flask with exactly 25 grams of liquid cocoa butter and put it in a water bath at 0 degrees Celsius. The cocoa butter will, of course, start to cool. There will be an exchange of heat, and finally, the butter will crystallize. When crystallizing, a release of energy will take place. The temperature will increase. The amount of increase divided by the time will give the Shukoff value, or Q. Additional information can be generated through a DSC analysis, in which we can describe a pattern of crystallization. In short, this method is based on the energy needed when melting a substance, such as a fat, or released when crystallizing it. Fats will perform differently according to their chemical composition and physical structure. Comparing the graphs will give you more background information on the fat's actual crystallization behavior. To obtain maximum brightness for white chocolate, we can supply a special quality of cocoa butter which has a completely transparent color. Our application lab is equipped with small-scale machinery to perform pilot tests. So we can supply both technical knowledge as well as the best raw materials to optimize your recipe formulations. Compound coatings give us the impression of chocolate. In compounds and coatings, cocoa butter is replaced by a vegetable fat other than cocoa butter, and in many cases, the cocoa mass is substituted by cocoa powder. Coatings may be used instead of chocolate for economic reasons, as the cocoa butter component at times may be a significant cost factor, but also for functional reasons, where coatings made with a more elastic vegetable fat can be used to coat a cake. Chocolate would be too brittle to be cut with a knife. The color of coating is determined by the type of cocoa used. Natural cocoas will give a yellowish-brown type of color, similar to that of chocolates. The darker alkalized cocoas give a more reddish-brown hue. and can be used in lower dosage than natural cocos in order to achieve the same darkness. The color of coating is further determined by the quantity of cocoa used. Compounds are generally rather dark due to the high level of cocoa. Increasing the amount of cocoa might not be the most effective way to improve darkness. Stronger, alkalized cocoa may show better results, even at a lower dosage. The flavor of compound coatings is determined by the type of cocoa powder used. A natural process, or non-alkalized cocoa flavor, resembles the flavor profile of that of chocolate rather well, because the cocoa mass used in the chocolate is also a natural process. Alkalized cocos perform well and give a different character to the taste, making the product round, not as astringent, less sour, and less fruity. A combination of natural and alkalized cocoa may have additional value, as here we can find in the taste the natural components that have a similarity to chocolate, as well as the more developed round taste of the alkalized cocoa. The flavor of compound coatings is further determined by the quantity of cocoa used. It's amazing how the dosage of cocoa powder can change the taste perception of a compound coating. A low dosage of cocoa in a given recipe may give a smooth, milky chocolate impression, where a higher dosage of the same cocoa may give you a strong and intense cocoa impact that in no way seems to resemble the profile of the low-dosed product. The quality of the cocoa powder used in compounds is of specific interest in the field of natural cocos. We should take into account that for this group of applications generally, parameters such as fineness and microbiological standards are not felt to be of great importance. For this reason, coatings seem to be suitable for the inferior type of natural cocoa that is found in the market, generated as a byproduct of the domestic manufacturing of cocoa butter from cocoa beans that do not meet export quality standards. At Cargill, we often experience that it's underestimated how positive the impact of good quality natural cocoa is compared to second-grade cocoa. We also advise to be conservative in the dosage of cocoa, because the strong flavor impact may be overpowering and result in a too bitter taste. So, when choosing a good cocoa powder, choose the Gherkins brand from Cargill. In bakery applications, the widest variety of cocoa powder is used. Depending on the type of application, whether it's a cookie, cake, brownie, or another baking application, taste and color properties vary through the use of different cocoa powders. We can split bakery applications into two groups, based on different moisture content. The first group is the dry applications, such as cookies, which have a hard structure. The second group is wet applications, with a more soft structure, like cakes or brownies. In dry applications, the widest variety of cocoa powders is used, from yellowish natural cocoa powder up to black, strong alkalized cocoa powder. In these applications, color is more important than taste. Due to the baking process and the ingredients used, taste differences are hard to recognize. For wet applications, such as brownies, the impact of the type of cocoa powder on the taste is significant. Natural cocoa powders give a sour, hay-like taste to these products. To obtain a stronger cocoa and a more chocolate-like taste, it's good to use an alkalized cocoa powder. Dark cocoa powders, such as GT 150, give a highly appreciated color and taste sensation in a brownie recipe. In these wet applications, stronger alkalized cocoa powders are used for both color and taste characteristics. The application of extruded breakfast cereals can be seen as both a dry and a wet application. The product, as such, can be seen as a dry application, but consumed with milk or yogurt, the product is more a wet application, where taste is also of great importance. In order to get a good baking result, the following cocoa powder characteristics are of importance. Fat content. Using a high-fat cocoa powder can lead to more viscous dough and a more compact end product, as the cocoa butter has a negative effect on the rising result. On the other hand, a higher cocoa butter content will give a more chocolate-like taste and a more smooth, tender mouthfeel. Another aspect is the pH value of the cocoa powder. Due to the addition of alkali during the alkalization process, particles of free alkali may still be present in the dough and can work as a leavening agent in the baking process. The stronger the alkalization process of the cocoa powder, the more extra rising effect will be noticed on the application. Adjustment of the amount of baking salts in the original recipe may be necessary to prevent bakings from collapsing or breaking. Moist content. The moist content in a recipe must be considered when using cocoa powder. Cocoa powder absorbs more water compared to flour, which may lead to more viscous dough. It also results in a drier, less tasty product, which breaks more easily after baking. To avoid these side effects, you need to add more water compared to a recipe without cocoa powder. Remember that stronger alkalized cocoa powders tend to absorb more water than natural cocoa powder. All of these things have to be considered when choosing a special type of cocoa powder for your application. At Cargill Cocoa, we have equipment to do baking tests on all kinds of bakery applications using different types of cocoa. Our technical department can and will offer you advice about the behavior of cocoa powder in your specific application, not only in the bakery section, but also in every possible application. We'll find the right cocoa powder for you, delivered to your plant and supported by our technical knowledge. Instant chocolate products are a special group of end products in the dairy and bakery segments. Think of drink mixes, mixes for vending machines, dessert and bakery mixes. Other than the ready-made chocolate drinks and desserts, these products are made into end products at the same time or closely before the moment of consumption. Cocoa powder itself has poor cold wetting properties. It often needs a little help to become instant, easily dispersible in the water or milk. The cocoa butter present in the cocoa powder in a level of around 10% prevents the cocoa from dispersing readily. Starch and fiber, naturally present in cocoa, easily lead to the typical formation of dry lumps on a wet surface. To prevent this from happening at the powder stage, the emulsifier lecithin is added to the cocoa to form a bond with the cocoa butter. With the cocoa butter bonded to the emulsifier, a cocoa mixture will much more readily disperse in a cold solution. This effect is optimal only when the emulsifier is added to pure cocoa powder, as here the contact between fat and emulsifier is most intense. When, on the contrary, lecithin is added to a ready mix of sugar, milk and cocoa, a good part of emulsifier will not reach the cocoa fat, but will be lost on the other components that do not need emulsifier, as they are easily dispersible by themselves. Therefore, the best option for cold dispersible mixes is to have your cocoa lecithinated by Gherkin's Cacau. Granulation is a process to further improve the instant properties of a product. Here, crystal sugar is wetted to allow cocoa powder to stick on the wet outer surface of the particle. The heavy sugar particles will sink through the wet surface, taking the cocoa powder with it, where a dry mix that is not granulated would show sugar particles sinking into the cold fluid, leaving the lighter cocoa powder behind at the top. The agglomeration processes can be described as the wetting of powdered or icing sugar to create a sticky sugar solution on the surfaces of the particles, where many small particles cling loosely together to a desired size. If the degree of agglomeration is sufficient, the open, structured, sponge-like particles are able to disperse in water by allowing the liquid to be sucked into the small capillaries of the sponge-like agglomerates that then fall apart upon dispersion. Spray drying can also be used for the preparation of cocoa mixes. Cocoa powder is mixed into a liquid milk concentrate and sprayed by a wheel or nozzle into a drying tower. Agglomeration and drying of wet particles takes place in a fluid bed or rotary dryers. Here, the mixing of the cocoa and milk prior to drying has a positive effect on the final flavor. Drying, however, is a sensitive step, where cocoa flavor is easily lost.
Als ik zo bekijk, dan denk ik dat Monster erbij zit.
Our technical support team will help you optimize your instant mix by finding the right choice of cocoa by suggesting strong flavored cocoas that bring deep colors. They will further consult you on the sensitive parts of the instantizing process. So, with Gherkin's products and expertise, you are able to make that quality product the market is waiting for. Chocolate is a popular ice cream flavor, second only to vanilla. Chocolate flavor can be introduced to ice cream in several ways: as a ripple, as chocolate drops, or homogeneously as cocoa powder. Cocoa powder present in ice cream is part of an aerated frozen system with other ingredients and components, such as fat globules, ice crystals, sugar crystals, and minor ingredients such as stabilizers and emulsifiers. Part of the cocoa powder is dissolved and present in the liquid phase. The largest insoluble part, such as fat and fiber, is present in the solid phase. Ice cream manufacturing takes several steps, and the introduction of cocoa powder to the recipe requires special attention. Mixing and wetting of the dry ingredients, including cocoa powder, requires a lump-free cocoa powder to have maximum ease of preparing the mix. Pre-mixing cocoa powder with sugar is advised, as this eases the formation of a homogeneous, fully wetted suspension. Subsequent pasteurization is most effective if the raw materials are of a good microbiological quality. The microbiological quality, including the microbial spore count of the Gherkin's cocoa products, is very consistent and closely monitored. Ice cream mixes are homogenized, typically after pasteurization. The homogenization is required to produce the fat globule size distribution which is required for a well-structured frozen ice cream. Gherkin's cocoa powders are suitable to be part of a homogenized mix, as they are low in shell. A good separation of shell and nib, as well as consistent milling in our factories, creates cocoa powders with a minimum of coarse and hard particles, which could potentially be harmful to your equipment. After aging, the final steps in ice cream manufacturing are related to the freezing of the product. All ice creams contain some additional air or overrun, which is introduced when the product is in the freezing phase. For chocolate ice cream, the fading of the ice cream color resulting from the introduction of the air is sometimes a problem. It's inevitable, and after freezing, the product darkens, but always remains lighter than the product without air. Gherkin's cocoa powders are of consistent, intense color, which makes them suitable for use in aerated products such as ice creams. Generally, in dairy applications, the use of natural cocoa powders is less ideal. Ice cream, is no exception to that. Typically medium to strong alkalized dark brown to red-brown types are selected by our customers for use in their ice creams. The use of very strongly alkalized types is somewhat limited, due to the interaction of pH with certain stabilizers. Both full-fat and low-fat cocoa powder can be used in ice cream. The cocoa butter in cocoa powder plays a role in the structure and eating properties. The cocoa powder dosage is related not only to your personal preference, but also to the legal and technical options of your product. When we look at a standard cocoa powder recipe, we see that cocoa powder represents up to 2% of the dry solids. Premium recipes have a higher total solids content. They require more cocoa powder, and often a darker, full-fat cocoa powder type is used. The overrun percentage, which typically is around 50% of the final product, plays an important role in the final appearance of your product. Making the best choice of cocoa powder is an essential factor for the success of your product on the market. The technical capabilities of the Gherkins cocoa powders make them very suitable for use in ice creams. Gherkins Cocoa offers technical service from our team of technical experts who are happy to assist. Over the last few years, the pace of change in consumption trends has been enormous. Every year, millions of new ideas and products are launched by the food industry all over the world. The creativity and speed to respond to consumers can determine success in business. To help customers better cope with this, Cargill has created application technology centers. In order to serve clients outside the country, we have one in the USA and another in Europe. In Brazil, it's located in Mairinque, in the countryside of São Paulo state. The 3 centers are open to customers where they can test and create new ingredients, formulas, and end products. We can also give advice on many different subjects. A wide variety of tests can be conducted for diverse industry segments. Our technology experts can assist our clients to perform experiments in our pilot plants. They are able to perform application tests for the confectionery, bakery, dairy, ice cream industries, and many others. In addition to performance tests, Cargill has a panel for sensory evaluations to help identify the best ingredient match for development and to monitor the final quality of the product. By promoting this interaction with our technicians, we expect that our customers can reduce the time of their product development cycle as well as their success rate. All these facilities were built to be at your service. Our job is to seek solutions. Cocoa futures are traded on the exchanges in London and New York. The primary reason for trading futures is to cover or hedge the price risk involved when purchasing cocoa beans in countries of origin. Cocoa futures are also bought and sold for speculative purposes by investment funds and small speculators. The New York Exchange is a market where people buy and sell futures in a trading pit. In London, cocoa futures are traded electronically through computer screens. The price of the terminal months is mentioned on the board. Futures can be traded over a period of about 2 years ahead. The volatility of the market is determined by fundamental factors and by technical factors. Fundamentals are described by physical factors, such as crop size and weather. Technical factors are mainly based on charts and mathematical calculations. So, when you are assessing your strategy to purchase futures, beans, or cocoa products, you have to take into account both factors. At Cargill, Our team is in constant contact with markets and origin countries around the globe. So whenever you need some fresh information, just give us a call. Cargo has offices in many countries supplying different markets with its specific products. We can assist you in finding solutions for coverage, productivity, food safety, and product development. Our sales executives are prepared to share relevant information with our customers in many different ways. It doesn't matter whether the products are produced in Holland, Brazil, the Ivory Coast, or France. We guarantee they will always be within the tightest specifications. If you are looking for a good cocoa ingredient, food safety, timely delivery, advice, and special services at a competitive price, we can assist you. Cocoa beans are produced in tropical countries, but cocoa products are mainly consumed in European and North American countries. The old English colonies, such as Nigeria and Ghana, were the basis for the London future market. The French colonies, such as the Ivory Coast for Paris, and South American countries for New York. In the mid-80s, when Far East cocoa production was booming, a cocoa future market in Kuala Lumpur was established. In the end, the cocoa players in general agreed that 2 future markets were sufficient. Today, only New York and London remain open. These markets provide the price reference for many players in the cocoa chain. You can trade cocoa contracts on these markets just as on the stock market. The contract specifies the quantity to deliver. One contract is 10 metric tons, called one lot, and a period of delivery. Only a few calendar months can be traded for cocoa, called delivery months. March, May, July, September, and December are the standard delivery months for cocoa. A future contract has a price. The prices of the future markets are expressed per metric ton. New York works in US dollars and London in British pounds. The general conditions of a contract are the origin and the parameters of quality. The quality will be established by grading and could lead to discounts, but also premiums. Delivery location and the quality will only be known at the moment of delivery. Cocoa is a rather small commodity. Therefore, small changes in supply-demand or unrest in origin countries make this a very vulnerable commodity. Sales and purchases are rarely done at the same time. By doing nothing, large price changes can lead to big gains or losses. You may not want to take these risks, but like to have protection to bridge the gap between sales and purchases, called hedging.
It's a risky business.
Hedging your business is the way to get protection against price fluctuations on the cocoa market. At a certain moment you buy beans in the market, at the very same moment you sell the same quantity on one of the future markets. It's exactly the other way around when you sell the beans. In that case, you buy at the very same moment the same quantity on one of the future markets. The money you lose with the physical cocoa is compensated by the money you gain with the future contract, or paper cocoa. By hedging your physical business, purchases or sales at another price level at the same moment, the gain or loss on the physicals is compensated by the money you gain or lose on the cocoa future market. So, whether prices go up or go down, the physical cocoa price risk will be compensated by the paper cocoa price risk. The difference between physical and futures, called the differential, is the only thing you have to manage. As an exporter, for example in the Ivory Coast, you buy your cocoa beans from the cooperatives or intermediates. Before you can export the cocoa and sell it to a trade house or industry, you'll have a lot of costs, such as receiving the cocoa in your warehouse, cleaning and drying the cocoa, packing it in new jute bags or stuffing it in containers, paying the export taxes, loading the parcels in a ship, paying transport and insurance, financing the cocoa, paying the warehousing, and so on. Let's say the total cost is around £400 per metric ton. Let's assume you buy the cocoa beans at £1,155 and you could sell the futures against it at £1,500 per metric ton. You buy the cocoa beans at £345 per metric ton under the price of the futures market, a differential of minus £345. Now the cocoa beans are in a warehouse in Amsterdam. The market declines, and the price of the future market is at £500. You can find a buyer and sell him your cocoa at £565 per metric ton. This leaves you a differential of plus 65 per metric ton. Total gain equals purchase at minus 345, sales at plus 65, which is £410 per metric ton. Your total cost from farmer to the warehouse in Amsterdam was 400, so only a small gain of £10 per metric ton is made. What have we done? Yes, we have managed our risk. By hedging against our purchase and sale of the physical cocoa, we have protected ourselves against potentially very high losses. No hedging, a purchase at 1,155 plus costs of 400 and a sale at 565 would have been a loss of £990. By hedging, we sold and bought the futures at 1,500 and 500, which gave a gain of £1,000 per metric ton. The difference is a small gain of 10 per metric ton. So, the difference between physical and futures, called the differential, is the only thing you have to manage. The level of the differential and changes are an important part of the product price for the cocoa industry, trade houses, and exporters. All professional players hedge their physical business on the future markets in London and New York. World cocoa price changes, which are reflected in the price of the future markets, are important for the investors. In this way, you have players on the future markets with opposite interests, which gives liquidity.
Remember, it's a risky business, and you don't want to run unnecessary risks.
Cocoa prices are volatile. This means prices change a lot over time. There are basically two sets of factors affecting cocoa world markets. The first set has to do with the cocoa supply and demand and is called the cocoa fundamental side. And the second has to do with factors outside the cocoa market. This second set includes all kinds of elements, such as, for example, inflation fears or a movement in other commodities, which prompt speculators and investment funds to take positions, buying or selling, in cocoa markets. In the long run, however, cocoa markets always find price equilibrium based on cocoa fundamentals. As a result, fundamentals are very important to understand. The fundamental driver of cocoa world markets is the balance between the crop size, supply, and the bean grind, demand. If the crops are bigger than the grind, there is a surplus and stocks increase. If the crops are smaller than the grind, there is a deficit and stocks decrease. Surpluses tend to push prices down, while deficits pull prices up. This system is dynamic, as price influences both crops and grind. A low price boosts consumption and increases demand, but discourages producers. A high price motivates farmers to produce more, but can slow demand. Let's look at the drivers on the supply side first. Cocoa is a tree crop. It takes 6 years for a newly planted cocoa tree to reach full production, meaning that a structural increase in the crop by new planting will only become visible after several years. This implies that the reaction time to restore the balance between supply and demand is long. There is also a more short-term impact on the price of cocoa production: farm maintenance. When prices are good, farmers will quickly increase production, first by working harder on their cocoa farm on weeding and pruning. If they have enough cash, they will also buy pesticides to protect the fruit and the trees from insects and diseases. Finally, if they have even more cash, they will buy fertilizers to boost future crops. But in the case of low prices, farmers will reduce work on the farms and have to focus on other activities. The price paid to the farmer depends on a number of factors, including the level of the cocoa market, plus minus the premium or discount of a certain type of bean. Political decisions, stability, taxes, incentives to the farmer community. Costs of bringing the cocoa to the market, distance, condition of the roads, infrastructure. The other major driver of the crop size is the weather. Drier than normal weather usually reduces the size of the crop. Lack of water results in poor fruit survival and small bean size. Very wet weather, like an El Niño event in Ecuador, favors the development of fungal diseases that cause the fruit to rot on the cocoa trees. In West Africa, the period July-August is often referred to as the silly season. The fruit is in full development, and the weather pattern includes a mini dry season. If that mini dry season is longer than normal, losses will occur. If the rains return on time, the cocoa crop will increase. There is a lot of speculative activity during this period as a result. Now let's look at the other part of the supply and demand equation, demand. In the first instance, 3 intermediate products are made from the cocoa bean: cocoa liquor, cocoa butter, and cocoa powder. Virtually all of the cocoa liquor and butter is used to produce chocolate. Powder is used in all products with a chocolate flavor, except for chocolate itself. To understand cocoa demand, you need to watch the supply and demand for beans, chocolate, as well as powder. Liquor is the essential ingredient to give chocolate its fine flavor and color. In addition, butter is needed for the mouth-feel of chocolate. The combined value of butter and liquor is the main part of the ingredient price of chocolate. In most countries, a small part of the butter can be replaced by CBEs, or cocoa butter equivalents. Depending on the price differences between these CBEs and cocoa butter, and depending on technical requirements, some substitution may or may not take place. The powder demand is more complex. Powder is used in many different applications, such as dairy, bakery, compound coatings, dry mixes, tobacco, etc. Moreover, in most consumer goods, only very small amounts of cocoa powder are needed to change the color and flavor dramatically. The requirements of the industries on color and flavor, but also on other technical aspects and product safety, vary per application, And even in each application, individual industries look for high, medium, or low quality powders. This means that there's no such thing as one cocoa powder market. There are many powder markets. Contrary to cocoa butter, there is no real substitute for cocoa powder. Looking back at the flowchart, the physical balance between the supply and demand for beans results from adding or reducing world stocks. The pricing mechanism will force that supply and demand to be in check over time. All beans are converted into cocoa liquor, but liquor has two destinations. The first is liquor as an ingredient for chocolate, and the second is liquor that will be pressed into butter and powder. This means that chocolate basically drives the demand for butter and liquor. Powder is ruled by its own demand, independent of the chocolate industry. Chocolate and powder consumption is influenced by prices, purchasing power of the consumer, culture, climate. For example, hot weather usually results in poor chocolate consumption, but cocoa ice cream demand is boosted. So in this case, we face a decrease of liquor and butter demand, but an increase in cocoa powder demand. To summarize, the cocoa market is just like a chair with three legs: crops, chocolate demand, and powder demand. These three legs are tied together because of the physical process of cocoa. You need beans to make liquor, and you cannot make butter without powder. To really understand the fundamentals of the market, you need to understand each of the three legs. The prices of liquor, butter, and powder are related to the price of beans, because it is the raw material for all the products. But the prices of liquor, butter, and powder don't strictly follow the price of beans, because each product has its own supply, demand, and stock level. When the relative value of butter, the butter ratio, increases, the powder price usually decreases, and the opposite is true as well. Both products are produced from the same bean. Mostly butter captures the higher portion of the combined value, but again, history has shown exceptions are possible. To better understand the dynamics, Cargill has a market research department where we monitor crop developments in all important origin countries, global and local trade flow data for cocoa beans and products, global and local bean grind and consumption, and global and regional stocks and price developments. Cargill is the largest cocoa bean grinder in the world. We have factories in 8 countries producing high-quality products for our customers. Because we use a very significant share of the world's crop, we developed strategies to secure our business. We started our own sourcing operations in the top producing countries: in Brazil in 1980, in Nigeria in 1991, in Indonesia and Cameroon in 1996, and finally in the Ivory Coast in 1998. In the main areas, we built several up-country buying stations in order to get as close as feasible to the producers. Thanks to this network, we are always close to what's happening in the field. We allow maximum farmer remuneration by cutting the number of intermediaries in the supply chain. And we ensure ourselves a supply of high-quality beans. Cargill has also developed a dedicated market research center. It's where we gather and compile information on local and worldwide supply and demand. We make our own original fundamental analysis of the markets. To do this, we have teams in the top producing countries which visit hundreds of farms every week, all year long, and count the cocoa fruit on selected trees. The data is processed in the Netherlands for statistical analysis. This dedicated team also monitors the weather, especially rainfall data. Another important action is to monitor the flow of cocoa arrivals in the ports and the available stock levels. By analyzing and combining all the information, we have an estimate of volume of the cocoa crop worldwide and when it will come to market. In the Research Center, we are continuously feeding our comprehensive database containing import, export, and price information about cocoa products and its derivatives. We also study detailed trade flows to create demand analysis. In this way, we ensure consistency and reliability of the results. This market information is original and unique and is not available outside cargo. However, for good customers, we are happy to share our views and some of our results during discussions, through advice or during visits, and through presentations.